Alright, hello once again. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD 1112 Application Programming with Java class, I'm doing a series of video presentations based on the books used for the class. The first book, as you can see here, is Java Quick Syntax Reference. There are 22, actually 23 chapters in the book, and I've gone through the first 12, which puts us into Chapter 13 on overriding. And it says here, a member of a subclass can redefine a member of the superclass. This is most often done to give instance methods new implementations. In the example below, the rectangle's get area is going to be overridden by triangle. Alright, so in other words, the way that you get an area for a rectangle is different than the way you get an area for a triangle. Alright, now there's nothing wrong with the example the authors have here. Probably rather than doing it like this, we would have created a class shape up here. And all shapes, I don't know if they have anything in common, but we would have said something. And then we would have done class area extends shape, and also class triangle extends shape, because technically a triangle isn't a type of rectangle. But there isn't anything wrong with what the author has done. Alright? So, we've got our class rectangle here. Alright? And let's come in, at least try this. Alright, and I'm going to right mouse click on here again, and I'm going to do a new Java class, and I'm going to call it triangle. Since I've called them my class 2 and my rectangle 2, I'm going to call that triangle 2. Alright, and the superclass is going to be a rectangle. Alright, so notice it automatically says, oh, I did it wrong. So that's interesting. Oh, it should have been rectangle 2. Import rectangle 2. Oh, and it's still giving me a problem. And it's not rectangle 2. It is my rectangle 2. Oh my goodness. So that one worked. This didn't. I'm not sure why. I don't even think I'll need this, but we'll find out in just a minute. Alright. So, this will automatically have everything. This will automatically have everything a rectangle will have. Alright. Except the area will be done differently. In here, we're going to just put in this. Okay, and again, don't worry about it. We'll go over it in just a couple minutes. So I'm going to go back to my triangle 2, which I should have again called my triangle 2, but I didn't. So public get area. All right. So we've got return W times H. I'm wondering if this would work if I put in width and if I put in height here, because that's what I actually call them. At least oh, it's width and length, I'm sorry. There. So what that means is when I create a rectangle, all right, when I create a rectangle, I can either give it nothing, in which case it's going to set the length and width like this, or I can give it a length and width, in which case it'll set it like this. But when I call get area, rather than it calling this one, it will call this one. Let's prove that right now. So I now have my rectangles. And I'm going to come in here, and after I do this, I'm going to also create a couple triangles. So triangle 2, should have been my triangle, I'm sorry. T equals new triangle 2. Let's call it first and pass nothing in. And then let's call it again. And we'll call it U equals new triangle 2. And this time we will pass in what we passed in before, 8 and 20. All right. Not sure why I'm getting that error. Int. Triangle 2 cannot be applied. No, it doesn't like the second one. All right, for now, let's just comment that out. All right, now I'm going to grab this. I don't need my triangle count anymore, so you already saw that worked. So this is going to say the length is T dot length for triangle. The width is T dot width, and the area is T dot area. Now, if this works the way that it should work, all right, when I create this instance of a triangle, it'll come over here, and it'll say, oh, I don't have a constructor. So it says, let me go back to my parent's constructor, which is here. Since I passed in nothing, it'll say set the length to 20, set the width to 50. Then it's calling get area. But it comes back here and it says, do I have a get area? Yes, I do. So it takes the 20 times 50, which is 1,000, divides it by 2, so the area there should be 500. Let's indeed see if I'm correct. So there's our first triangle. I'm sorry, our first rectangle. Our second rectangle, there's our triangle. 20, 50, 500. Again, it would have been a little nicer if your instructor here had put in a \n at the beginning. Now it'll be a little easier for you to read. All right, so there's rectangle 1, rectangle 2, and the triangle. Now, if I wanted to make that a little easier to understand, I probably could have come in here and said this. Rectangle 1. All right, something like that. And then rectangle 2. And then finally, I guess that I would have needed a \n there as well. And this would have said triangle 1. Again, this is all about trying to make it as easy for you to see and understand as possible. So now when I look at this, rectangle 1, rectangle 2, triangle 2. All right? So hopefully that made some sense. Now, the author says here, in order to show this override was intentional, the override annotation should be used before the method. So I should have had that in there. It is implied otherwise, but as it says, it's done to prevent accidental overrides. So what I'm doing is I'm sending this a signal into the system, yeah, I meant to do that. All right. If you don't, again, it's implied, but it's just considered a safer way of programming. So let's get this back down here, bring back up the triangle, and put in the override. Okay? All right, that's what I just mentioned. Okay. It says there, if a class method called new area is added to a rectangle and redefined in triangle, then triangle's version of the method will be used, and it will hide the one from the parent. So if you want to hide something, you don't use the override. All right? So they've got new area here and new area there. Okay? So it says calling new area from triangle's interface will, as expected, invoke this one. But calling it from rectangle will invoke this one. Redefined instance methods will always be overridden in Java, and redefined class methods will always be hidden. There's no way to change this behavior as can be done in other languages. All right. So, preventing method inheritance. If you use the word final, which we haven't gotten into yet, but as you'll see in Chapter 16, final is also used for constants. But if you put the word final before a method, or you can do it before a class, all right, then it becomes something that cannot be overridden. So if you want to prevent a method from being overridden, you put the word final before it. If you want a class to be overridden, you put the word final before it. All right? It says the order of these modifiers is not optional. So it has to be public, which is the access modifier, final, all right, which is the preventer, so to speak, and int, which is the return type. Really, you should strive in a true object-oriented environment not to do this. And the reason for that is there's nothing wrong with constants, but typically you don't want to allow your methods and your classes to be final, because that means that they're leaf nodes. They end right there. They cannot be overridden. And along the line somewhere, someone might want to override something you've done. All right. Now, an overridden method can still be accessed from inside of the instance methods by using the super. Now, what I'm going to show you is something you would probably never want to do. All right? But if I wanted to, right here, let's just say I wanted to create a variable or do something where I wanted to be able to use not the get area from here, but the get area from here, I could use super.getArea. All right, so again, I don't know why I would ever want to do this, but notice if I come into here and I say, I don't know if this will even work, super.getArea. All right. It says it cannot be referenced from a static content. There are ways that you can actually use this. This is not a good example right here of being able to use all this stuff. But we will be going through some. I'm going to be writing some code after I get done with the book that's going to show you some of the stuff that it's kind of hard to go and look at in here. So there's calling the parent constructor. So if the first line is not a call to another constructor, the Java compiler automatically calls the parent. Guess what? You already knew that. The reason that you already knew that is when we went into Triangle 2, there was no constructor. Or really, there was a constructor here that was public Triangle 2 that did nothing. That's what was in there. So what the author is saying is technically what happened right there was it did this. And you don't have to type this in. You can, but again, it is superfluous or redundant to do what I'm doing right here. But you could put in super like that. Shouldn't get any error. And when I save this and run it, I should have the exact same output as what I had before. And you'll notice I do. Just notice something, and it's not that important, but let's get rid of these. here on the end. Run that one more time. Look a little nicer. There we go. Rectangle 1, rectangle 2, and triangle 1. All right. We're making some progress here. And we've come to the end of another chapter. So I'll come back in just a minute to go through Chapter 14, which is packages and the import statement. And I'll be back with that shortly.